This video is about extraneous solutions. This is a topic that comes up when you use rational expressions. An extraneous solution means that it's not a real solution. It's an extra solution. You might notice that extra is even in the name extraneous. But it goes beyond extra. It means extra and not true. So it's sort of like a false solution. It's a solution that you cannot use with a real problem. It's a solution that doesn't make sense. In order to talk about extraneous solutions, though, we have to remind ourselves a little bit about division and fractions and their interaction. So hopefully you all remember that a fraction is a division problem. 3 over 2 means, what is 3 divided by 2? And even rational expressions, I have x squared over y, that's the same as, what is x squared divided by y? And now because x and y are variables, x and y can be any set of numbers, we can't actually do this division like we can with 3 and 2, and get a nice pretty 1.5. But there are some things that we need to be careful about when we're doing division. In order to highlight those, we need to know what division means. So 20 divided by 4 means, how many 4s does it take to get 20? And we know our multiplication facts, and we know that it takes 5, or we could actually, write it out, and we see that 4 plus 4 plus 4 plus 4 plus 4 gives us 20, so it takes 5 4s. And this works for every single division problem. If I have 2001 divided by 3.46, or that actually looks like 3.76, or 3.96 actually. We'll just call it 3.96. How many 3.96s does it take to get? And if we were to list all the 3.96s out until we got to 2001, we would see that it takes 505.3 3.96s to get 2001. Now, this works really nicely for everything that we're dividing, except for when we divide by 0. Now, hopefully, when I say divide by 0, something pops into your head like there's a special rule for this. I'm supposed to know something about dividing by 0. And hopefully this explanation will make it clear what you're supposed to know about dividing by 0. So I'm just going to pick my favorite number, which is 5, and I'm going to try to divide that by 0. Now I want to remind you what this means is how many zeros does it take to get to 5? And so I'll start with 1 0. My total is 0. Well, that's not enough. I'll try adding another 0. Still at 0. Still at 0. Still at 0. And I can go on forever doing this, and I'll never get to 5. And now some of you may be, screaming at the computer right now, well, Mr. Sproul, you do it an infinite number of times and you'll get to 5. I want to remind you that infinity is a concept, not a number. We can't manipulate infinity. It's this idea that numbers go on for forever. It is itself not a number. So we can never get to 5 with zeros. We can never get to any number with zeros. And if you're curious about, well, what about 0 divided by 0? That's for another video, but it's an interesting question. What you need to know is that whenever you divide by 0, it's undefined. So divide by 0 means undefined. And this is the heart of extraneous solutions. If I go back to x squared over y, an extraneous solution would be y equals 0. I'd say that's extraneous. Because it doesn't work. We can't let y equal 0. Y is never allowed to be equal to 0 in this problem. And it's never allowed to equal 0 because we can't do that division when it's 0. So here I have another rational expression, x plus 1 times x plus 2 over x minus 3 times x plus 4. And I'm wondering, what are some extraneous solutions? What are some values of x that I cannot use for this problem? I remember that extraneous solutions mean that my denominator is equal to 0. And because I know about solving polynomials, I can write out when the denominator equals 0 pretty easily. I just write x minus 3 times x plus 4, because that's my denominator, and then right equals 0, because I want to know when this denominator equals 0. I'm going to use my zero product property. And that tells me that my denominator equals 0 when x minus 3 equals 0, and when x plus 4 equals 0. Well, x minus 3 equals 0 when x equals 3. X plus 4 equals 0 when x equals negative 4. That means my extraneous solutions are x equals 3 and x equals negative 4. Notice, I completely ignored my numerator. My numerator doesn't make a difference for me when I'm working with extraneous solutions. The only thing I care about is the denominator. The denominator is where extraneous solutions come from. Again, if you have any questions, please ask me in class or send me an email.